The Earth is about 70% ocean, if you look at its surface, and about 30% land. So the ocean dominates the characteristics that are going to control climate change. So one of the things that we're trying to work on is making sure that we understand gas exchange between the atmosphere and the ocean a little bit better. So right now, we have a pretty good understanding of how gases are exchanged at different wind speeds for certain gases that have been studied. But we don't have a really good understanding for different kinds of gases and how different molecular structures respond. A few years ago, some scientists were out in the ocean and they were measuring gas exchange of different gases at the same time and then comparing them. And they found that the carbon dioxide values of fluxes between the ocean and the atmosphere were going up with wind speed the way they were predicting. And then they looked at some other gases that were a little bit different. And one of them in particular was di-methyl sulfide. And this gas wasn't behaving exactly the same way. In fact, it was going up, but then it started to taper off and steady off and flatline. So we thought that perhaps it has something to do with the chemistry of the compound, because we know carbon dioxide is a neutral gas, but we know di-methyl sulfide, it's a polar molecule. So its electrons are not always equally shared among the whole volume, the whole molecule. So we decided that we should take a closer look at di-methyl sulfide and see what might happen to it when these two fluids are interacting and the fluid, the air and the ocean, start to change the way they're interacting. So when these wind speeds go really high, one of the things that happens is that there are a lot of bubbles that are being made and breaking waves, and these waves actually cause two types of exchanges. They make sea spray droplets, where water particles go into the atmosphere and exchange in that direction, but they also make a lot of bubbles that are going in the opposite direction. So they take air parcels and they inject them pretty deep into the water. So if we can figure out how gases and molecules that are chemically different exchange between the atmosphere and the ocean, then we can figure out how to really design our climate-based models and make better predictions for our future climate.